let us look at few more problems of solving the recurrent solution. So the first problem is solve an equal to 2, an minus 1, minus an minus 2, where a0 is equal to 1 and a1 is equal to 0. So the characteristic equation is, so we will get x raised to n minus 2, x raised to n minus 1 plus 2, x raised to n minus 2 equal to 0. So cancel out x raised to n minus 2. So that will be x square minus 2x plus 2 is equal to 0. So x is going to be 2 plus or minus root of 4 minus 4 into 2 divided by 2. So that will be 2 plus or minus 2y by 2. So that is 1 plus or minus I. So therefore we will get an equal to a 1 plus I whole raised to n plus b 1 minus I whole raised to n. Now when you take 1 plus I, so let us represent it in terms of cos and sin. 1 plus I, so you have x equal to 1 and y equal to 1, so this will be equal to, so r is going to be, so this will be equal to r e raised to I theta, so r will be root of 1 plus 1, so that will be root 2, theta will be equal to tan inverse of y by x, so that is tan inverse of 1, so we will get pi by 4. From 1 plus I ne you can write as root 2 e raised to I pi by 4 and whole power n, and b can be written as root 2 e raised to minus I pi by 4 whole power n. So that will give a root 2 whole power n e raised to I n pi by 4 varum plus b root 2 whole power n e raised to minus I n pi by 4. So that can be written as, so we will get a root 2 whole power n, then this is cos n pi by 4 plus I sin n pi by 4, then plus b root 2 whole power n and cos n pi by 4 minus I sin n pi by 4. So taking the coefficients of cos n pi by 4, so we'll get root 2 whole power n cos n by 4 into a plus b plus root 2 whole power n sin n pi by 4 into I minus. So this can be written as c cos n pi by 4 plus d sin n pi by 4 into root 2 whole power n. So here a plus b is equal to c and a minus b into I is equal to d. And now we have the value of a n as root 2 whole power n c cos n pi by 4 plus d sin n pi by 4. So let us find out the value of c and d. So നമുക്ക് constants in so a plus b can be put equal to c and a minus b into I is equal to d. So c and d are arbitrary constants. അപ്പോൾ നമുക്ക് imaginary വരുന്ന term ഇതിനകത്തുനിന്ന് remove ചെയ്യാം. Okay. And now we will use the initial conditions and find the value of C and D. So the initial conditions are A naught equal to 1 and A1 is equal to 0. So A naught equal to 1 and N equal to 0 in the case. So that will be C. So cos 0 is 1. So C will be equal to 1. A1 in the case root 2. C by root 2 plus D by root 2, it will be equal to 0. So we will get C plus D equal to 0. So therefore D will be equal to minus 1. So therefore the solution is N equal to root 2 root bar N. So we will get cos N pi by 4 minus sin N pi by 4. So that is the required solution. Then we have the roots to be complex. Now let us look at how to solve for a non-homogeneous equation. Let us look at how to solve for a general linear recurrence relation. So till now we have seen how to solve for a linear homogeneous recurrence relation. Now the general linear recurrence relation is of the form C naught an plus C1 an minus 1 plus etc. plus CR an minus r equal to f of n, where f of n is a function of n and C naught and CR are not equal to 0 and you have 1 less than or equal to r less than or equal to n. So here you have a right hand side function f of n. So this is called the rth order linear recurrence relation. Now let us look at how to solve for the equation. So there are three steps in finding the general solution. So first part of finding the solution is solving the associated homogeneous equation. So which we have seen past solution a and h. Then we need to find out the particular solution. Particular solution is a solution of the non-homogeneous equation. Then the general solution will be the sum of a and h and a and b. In the particular solution solving, that is similar to the method of undetermined coefficients. അതായത് നമ്മുടെ f of n similar ആയിട്ടുള്ള solution. So you are having a right hand side function f of n, you are taking the particular solution to be a function similar to that. And then by substituting into the entire equation, you will find the unknown constants. So let us solve an example of general linear recurrence relation. So solve an minus 3an minus 1 equal to 2 minus 2n square. So we are given that a naught is equal to 3. So the characteristic equation is, so that will be x raised to n minus 3, x raised to n minus 1 equal to 0. So that implies x minus 3 is 0. So therefore x is equal to 3. So therefore solution of the homogeneous part will be a 3 raised to n varum. Now here a and p that will be equal to, so it will be a function which is in the form 2 minus 2n square. That means we are having a polynomial in n. So let us take it to be bn square plus cn plus d. And now we will substitute in this equation. So an p minus 3an minus 1p, that will be equal to 2 minus 2n square. So we will get p n square plus cn plus d minus 3. an minus 1 p ആണ് വേണ്ടപ്പോൾ replace n by n minus 1. So we get b n minus 1 whole square plus c n minus 1 plus d equal to 2 minus 2 n square. So now that will be equal to bn square plus cn plus d minus 3b into n square minus 2n plus 1 minus 3c into n minus 1 minus 3d equal to 2 minus 2 n square. So let us compare the coefficients now. So coefficients of n square is minus 2b. So take the coefficient of n square. So minus 2b will be equal to minus 2. So that implies b is equal to 1. And next, let us take the coefficient of n. So that will be c plus 6b then minus 3c equal to 0. So we will get 6b minus 2c equal to 0. So that will give 6 equal to 2c. So therefore c will be equal to 3 and take the constant terms on both sides. So that will be d minus 3b plus 3c minus 3d. That will be equal to 2. So we will get minus 2d and minus 3 plus 9 equal to 2. So we get minus 2d plus 6 minus 4 items, so that implies d is equal to 2. So therefore an of p will be n square plus 3n plus 2. So therefore general solution will be an equal to, so we will get a 3 raised to n plus n square plus 3n plus 2. And now we are given an initial condition. So we have a naught equal to 3 and our solution is a 3 raised to n plus n square plus 3n plus 2. So a naught will be equal to, so when n is 0 you will get a plus 2. So that implies n plus, sorry, a plus 2 is equal to 3. So therefore a is equal to 1. So therefore the solution is an equal to 3 raised to n plus n square plus 3n plus, so that is the required solution. You need to solve an minus 3an minus 1 plus 2an minus 2 equal to 2 raised to n, then a naught equal to 3 and a1 equal to 8. So characteristic equation is x square minus 3x plus 2 equal to 0. So we get the roots to be 1 and 2. So an of h will be a 1 raised to n 1 now. So a plus b 2 raised to n. Now for finding an of p, on the right side we are having the function, so f of n is 2 raised to n. ഇനി നമ്മൾ മെത്തേഡ് കണ്ടിട്ടാണ് കോഎഫിഷ്യൻസിൽ അപ്പം റൈറ്റ് ഹാൻഡ് സൈഡ് ഫംഗ്ഷൻ ഇതിൻ്റെ സൊല്യൂഷൻ ആയിട്ട് വരുവാണെങ്കിൽ, so there we used to multiply with x. So similarly here we multiply with n. So here the solution will be of the form c n 2 raised to n.